Hi everyone, it's great to be here today. My name is Erin Robot Swirl, and today I'm joined with two little robot creatures. They can say hello. Now, they're a little shy right now since their natural habitat is the outdoors. And that's what this talk will explore. What happens when robots meet nature? I'm celebrating 10 years of bringing robots outdoors and hope to inspire you to do the same with your robots. Today we will cross into 3 different biomes: Terrestrial, Aquatic, and Aeolian, featuring 3 different robots in each with a grand eco mission. I'll share tips to apply to your own robots, including environmental factors to keep watch for, design considerations for the outdoors, community involvement, and a field learning lesson. The thing to keep in mind is that when robots are no longer in the controlled conditions of a lab bench, they may behave differently, especially when outdoors. There are so many variables. Now, here's the thing. These insights were all gleaned from hundreds of hours of developing and then bringing the robots outside, with plenty of learning lessons along the way. It's not exactly the theoretical knowledge that you would find in a textbook. This is all shared from the perspective of a robot maker. The designs might not be the way it would be done professionally, but it is the way it could be done in a small room while being resourceful. My hope for you after this talk is that you'll be energized to bring your own robots on an adventure outside of the lab and into the outdoors. At the end, I'll give a handy checklist for your next robot adventure. Let's get started. First up is the terrestrial biome, gazing out at the vast expanses to explore. Let's say hello to each terrestrial robot and hear what their focus is. Here's Manoi, the hockey-playing humanoid robot. Yeah, go Manoi, go! This robot brings extra flair with its ping-pong LEDs. Plus, not only did it love to just play hockey, but also telling other robots about it too through a mesh network. It eventually had to retire on account of its knee servo gears melting. Rapidly Deployable Automation System is an incognito robot that unfolds to perform the most distinguished of all duties, collecting cool rocks. It is guided by a teleop headband that senses movement. Once done, it could then be folded up again and brought to a different place. Here is Bowie the robot. Bowie loves to collect garbage on beaches. It scoops it up, puts it into its hopper, complete with a mechanized lid, of course, and then carries on its way. Bowie was designed with the constraint of being entirely 3D printable. This worked out well, with others replicating the robot pieces too. Okay, so we have our team set, and now let's go on an adventure with Bowie. Now, Bowie might be a little robot, but it was up against a large problem: plastic pollution. Perhaps you might have heard that by 2030 there will be more plastic than fish in the ocean. It's a problem that affects waterways happening all over Earth. Imagine a future where a team of these small robots could be combing the beach to collect garbage, preventing it from entering the waterways. Bowie could be either remotely operated or in autonomous mode by tracking markers. Bowie's wheels posed a difficult challenge. With the different textures of sand, sometimes the wheels would dig in making it get stuck. So how could this problem be overcome? Bigger motors, bigger wheels, those all could be solutions. Another possible solution are these funky wheels, actually spurred by a conversation at Hackaday SuperCon. Here's Bowie being tested at the Canadian Space Agency Lunar Terrain. To reach this point, it took 23 iterations, a constantly evolving robot where each iteration was driven based on the community and how they interacted with it. In its final form, Bowie used AI to detect garbage, had a laser pointer, and a claw. The community played an important role in this project. And you know, what's more inspiring than seeing people come together, both young and old, to cheer on this little robot helping out the local beach? It was truly a magnificent moment in time, sharing the excitement of combining robotics and the environment together. During the daily testing on the beach, there were lots of fun interactions with nature. On one hot summer day, a duck waddled up to the robot and sat in Bowie's shadow to cool off in the shade. It was so adorable. This leads to the field learning lesson. When operating robots in the outdoors, unexpected things happen. We should aim to let this unfold organically with gentle robots. Okay, now here's what you need to know when you bring your terrestrial robot into the outdoors in terms of environmental factors. Sand and dirt can be very sneaky, but at the same time, clever designs can help. For example, Bowie has all of these holes in its chassis. Most of the sand falls through these holes. As long as the electronics have their cover on it, it won't be too bad, though it won't be pristine either. The wheel motor housing has a hole almost the exact same size as the axle, and an inset coated with hot glue to prevent grains from going in the gearbox. The early version did not have that, and it did run into the issue where a single grain of sand broke the gearbox by shattering one of the tiny gears. Now, here are some things to keep in mind for the design. Breaking down a larger movement into micro movements can help in sandy terrain. I would say one consideration to point out here would be ground clearance, as it can be easily overlooked, but it can greatly assist in how your robot traverses the terrain. Okay, on to the next biome. Time to make a splash into the aquatic biome. Now, there's one robot on the aquatic team that doesn't quite fit, but it does swim, albeit with virtual space fish. This is Botbait, a tentacle mechanism robot. It swishes its tail around, which stirs the cosmic fish tank. It's a particle fluid dynamics visualization in action. The robot in the real world interacts with the fish in the virtual world. Next up is Aja, a low-cost pop-up fishing gear device, such as for lobster traps. This helps keep track of the gear to reduce the likelihood of it becoming lost. When gear does become lost, it can lead to dangerous whale entanglements. The robot activates its motor, which is magnetically coupled to a release mechanism, and then it pops up to the surface. All of the electronics fit inside a water bottle. Here's Otter Force 1, a robot to collect purple sea urchins. All of the electronics were enclosed into a waterproof ROV enclosure. The end caps were sealed with double O-rings, and to connect to the motors, it used these devices called cable glands with marine epoxy to seal it. Okay, that's our aquatic team, and now let's dive into the adventure. This here used to be a kelp forest, but the purple sea urchins have destroyed it. This has a massive ripple effect on the ecosystem, since otters find refuge within kelp forests. Otters do eat the urchins, but because there are so many now, they aren't as nutritious and therefore not as appealing. This entire imbalance was precipitated by a marine heat wave event that impacted the sea stars, which were unable to keep the urchins in check. Currently, the way this is being addressed is by divers collecting the urchins by hand. It's a noble effort. However, what if there are ways we could help their effort by making it go faster, or perhaps even operate autonomously, or even gather valuable sensor data? This was the impetus to build Otter Force One. Community involvement for Otter Force One reached its prime when a passerby in a park exclaimed, "That looks like something that will explode." So let's talk about community for Asia instead. Asia was a part of the Hackaday Dream Teams initiative for 2 summers during the pandemic. Designing Asia connected people from all over the world, from Leo in Venezuela, working on the electronics, to the Supply Frame Design Lab team in California, fabricating the pieces, to the shores of Lake Ontario for the design and testing, to discussing with a fisher in Oregon. During a time when we were all forced to spend time apart, this brought us together, despite the large geographic distances. Okay, now what about the field learning lesson for this biome? This one was a bit of a humorous surprise. As it turns out, an underwater robot can still function, even if it has water in its enclosure, just as long as the water doesn't touch the electronics. So, now you know. Okay, here's what you need to know for your aquatic robot. The point about turbidity and detritus is pertinent to field testing. If you're moving around in the water with your robot, you can kick up some dirt. So it's good to either account for time to wait for that to settle before starting the test, or be very diligent with how you are moving around. Even a rehearsal might be useful to practice the most optimal path. Now, while the detritus affects the optical clarity, in a way, it can be cool because it adds that really neat visual effect, giving it that whole mysterious underwater world vibe. Here's what to keep in mind when designing for the outdoors. The key one to point out here are the hooks on the robot for retrieval. This one I really noticed as important, going from Asia version 2, which had many sturdy points, to Otter Force 1, where there weren't as many sturdy ones. The day I was testing Otter Force 1, the waves were strong, and with such a large device, it was tricky to get it steady. If there was a handle on the top, in addition to the sides, it could have been a bit easier. So it may seem like a small detail, but it makes a big difference when field testing. Alright, that was a splash, and now on to the next biome. And with a gust of refreshing wind, we are in the Aeolian biome. Now, to be clear, Aeolian typically refers to harsh Arctic environments. In this instance, we use it to refer to a setting where wind is the dominant feature. Some of these robots interact with the wind directly, and others it is more symbolic in nature. Let's touch on those two first. First up is RoboBird, a bird character in the form of a cube. It did fly through the air once, albeit with a soft landing, but it kind of counts. Wearing different hats gives it different powers using an NFC sensor. Primarily for education, it dances around by flapping its wings and chirping its beak. Here it is trying to be part of the flock with its natural counterparts. Fluttering along next is Robot Butterfly, a minimalistic design with its elegant wings. It is a little robot buddy to bring with you on outdoors adventures. See how it flaps its wings in response to different sensors. When linked together, the robots can form an interactive performance. The robot was designed as an educational kit, specifically at the intermediate level, with the control and power board being manufactured in my room. Rolling on in next is Atmosfinder. Wait, what? It looks like a wild robot has appeared. Oh hey, that's Buddy 4000. Don't worry, it's a friendly robot. What's it going to do? Oh, looks like it's slowly flying through the air with a human assist. Alright, with a good landing. Thanks, Buddy. Okay, sorry about that. Buddy 4000 likes to be a bit of a show-off sometimes. Let's try that again. Rolling on in next is Atmosfinder. It has 2 sails to catch the wind with trim motors on the upper and lower edge of the sail. In the center of the roll cage are the electronics and sensor payload. This robot was brought to the Mars Desert Research Station, where I had the chance to test it while on an analog astronaut mission. Atmosfinder's bigger vision is to explore the southern pole of Mars, where there are CO2 gas jet eruptions, similar to geysers, which could give us new information about the formation of global dust storms, providing a ground truth to the orbiter data. Atmosfinder's structure is comprised of tubes. They are hollow and somewhat flexible. It makes a great material for the roll cage, but not so much for supporting the sails. Through some sheer luck, a crewmate noticed that the shelves in the green hab, which is the garden area, were sturdier and of the same diameter as the tubes. She went to quickly disassemble a shelf, and as it turns out, it worked. This saved the project, and we were able to continue testing. We tested interacting with the robot using computer vision. The robot completed an unassisted roll of 100 meters, and of course, there was party mode. As for community involvement for Atmosfinder, well, when we're on Mars, there aren't as many people. That said, the entire crew collaborated together on each other's experiments. And on Atmosfinder, by participating in the field tests, having meals ready, taking photo documentation, navigating the off-road vehicles, and more. There are many ways people can help out a project apart from the technical side. So, the field learning lesson for Aeolian is to make your structures flexible and compliant by default, but make reinforcements where you need things to be sturdy. Having the structure be flexible and springy helps make it less likely to break with all of the forces at play. Also, be careful with the wind. You can easily find yourself caught off guard with how quickly it can cause things to become out of control. Also, duct tape is incredibly useful. Do not forget to bring the duct tape. Here's what you need to know for your Aeolian robots. Okay, I'm not sure how many of you have seen this phenomenon, but in winter, sometimes the wind is so strong and the temperature is so cold that even the lamp posts begin to shake just as if they are shivering. That can happen to the sensors on your robot, especially if they are attached to a mast. So make sure you gather data and then account for filtering it. As well, sometimes there will be gusts of wind that can throw off sensor readings. Here's what to keep in mind when designing the Aeolian robots. A surprisingly good and inexpensive material for sales are magic carpets. It's a type of toboggan, and you can get them for cheap in winter time. They can roll up, and you can punch holes in them to thread zip ties through or string through. And they're low friction, suspiciously similar to Delrin material. What's funny about the wind and robots is that with a robot, you can turn it off and it will stop. With the wind, there is no stop button. So you have to come up with a way to keep the robot in place and stowed when you want it to stop. That's a wrap on our 3 biomes. The common thread that links all of these robots together is community. Inviting people to be part of the robot, whether it's the development or an event, it makes it into a shared experience. When we bring robots into the outdoors, places where people least expect it, it meets them where they are at to be curious about the robot and interact with it. This interaction becomes a form of testing, along with seeing how the field can shape the robot. If there's one thing that I have noticed from all of the field tests where we invite the public to join in, is that everyone has an idea to contribute. And it's a really nice thing when people help out all these robots. And I'm grateful for all of it, no matter how big or small the contribution. Now, those robots were all well and complete, but they don't really look like that while they are in progress. So in true maker style, time to share a work in progress. The next biome is lava. This is a long duration project. It will use ceramics as a shell to protect from heat. Forms are made using 3D printing with a reaction diffusion pattern added onto the model, making it look organic. The initial tests are back from the kiln, and it's an exciting start. So far, there have been 50 experiments, and I'll be posting more progress logs as I continue building. Now, I hope some of you will have the chance to explore this beautiful region with your robots. Here's a handy checklist before you head out. For the environment, remember that you are a guest in nature's home, so it would be best to treat it with respect. For the robot, have a way to comfortably carry or stow the robot on long treks. It is ideal to have both hands free during the hiking portions. For the human factors, have a plan, a turnaround rule, and keep an eye out on the surroundings. Finally, the most important tool in your kit is patience. With that, I will leave you with this. When you bring robots on an adventure, not only are you building the robot, but you're also building moments with others and nature together. Thank you so much for being part of the journey, and hope to see you on an outdoor robot adventure sometime.